Welcome back to Science Click. Today, waves. Let's consider a rope. When we shake one end of the rope, something strange happens. The disturbance we create at one end seems to travel along the rope until it reaches the other end. This process of propagation through space is what we call a wave. To understand how these disturbances travel along the rope, let's see what happens at the atomic scale. We can imagine the rope as a long chain made up of successive atoms. These atoms all interact with their neighbours as if they were connected by springs. As with a spring, if we try to bring two atoms closer, they generate a repulsive force which pushes them apart. Conversely, if we try to separate them, they produce an attractive force that pulls them back together. Now let's see what happens if we lift the first atom on the rope. We've displaced it in such a way that this atom has been pulled away from its neighbour. As a result, it attracts that neighbour as if both atoms were joined by a spring. Under this pull, the next atom along is in turn slightly lifted and starts to pull on the next one. Step by step, the atoms pull on one another, and the movement applied to the initial atom propagates all along the rope. Through this experiment, we can better understand the phenomenon of propagation. When we disturb one end of the rope, we give energy to the first link. That link then relaxes and passes the energy on to the next, which in turn transfers it to the following one, and so on. A wave is therefore not the movement of an object, but a propagation of energy. Waves have interesting properties. For example, if one end of the rope is fixed and we send a wave towards it, the wave will reflect and travel back in the opposite direction, as if it had bounced off a wall. Another interesting effect occurs when two waves meet. They add up against each other. A crest and another crest will combine at the moment they meet to form a crest twice as high. Conversely, a wave with its exact opposite will cancel each other out. In our world, waves can be found almost everywhere. Some waves travel in one dimension, along a line, as with the rope. Others spread over two-dimensional surfaces, such as a ripple on the water's surface. Finally, since our space has three dimensions, there are waves that propagate in all directions, such as sound waves. All these waves travel through some kind of matter, along the rope, across the water's surface, or through air molecules. However, there are also waves that need no material to propagate. For instance, the coupling of electric and magnetic fields gives rise to what we call electromagnetic waves. These electromagnetic waves can travel through the vacuum. They don't need any matter to carry them. They make up the light and colours we see, as well as X-rays, ultraviolet rays, infrared radiation, and a whole range of other waves invisible to our eyes. Finally, all objects that possess mass distort spacetime. This distortion bends the paths of objects. For instance, the Earth orbits the Sun because the Sun warps spacetime around it. Just like with ripples on the water surface, if extremely massive objects were to move very rapidly, as happens when two black holes merge, they generate waves. These waves in spacetime spread through the universe, distorting it as they pass. They are what we call gravitational waves.